Okay, I'm going to be talking about lipoproteins. So what are lipoproteins, you may ask? Well, let me tell you. They're lipids and proteins. So proteins, I think we've all heard that muscle weighs more than fat. So proteins are heavier than fat. We have a few different kinds of lipoproteins. There's chylomicrons, VLDL, IDL, LDL, and HDL. And they're going in order from least to most dense. And what makes this the least dense is that it has the highest fat component. And what makes HDL high density is that it has the highest amount of protein component out of all of the lipoproteins. Now, this part is where it gets confusing, so I hope I could clarify this for somebody. So, we either eat fat and cholesterol from food, or we make it in the liver. So if we make it, it's known as endogenous fat. And if we eat it, it's known as exogenous fat. So if we take exogenous fat from food, our enterocytes in our intestines are going to absorb the fat and package it into a chylomicron. Chylomicrons are going to go to the lymph, then they're going to go to the blood, and then they're going to drop off tags to adipocytes. VLDL is similar in that it has the same job as a chylomicron, but they're transporting two different things. So VLDL is coming from the liver, and then it's going to drop off tags to adipocytes as well. So just keep this together in your head, that VLDL and chylomicrons are both dropping off tags. It's just that chylomicrons are going to drop off tags from food that we ate, and VLDL is going to drop off tags that we made in the liver. So when VLDL and chylomicrons drop off tags, the way that they do that is through lipoprotein lipase. So this is an enzyme. So lipases cut lipids, and we're talking about lipoproteins here. So lipoprotein lipase is sitting on the surface of adipocytes and other cells, but we're focusing on fat tissue here. So lipoprotein lipase is sitting on the surface of a cell waiting for either VLDL or a chylomicron, and it's going to cut the tags out of a VLDL or chylomicron and place it into an adipocyte so that the adipocyte can store the tags for later. So the chylomicrons, once they drop off tags, they're going to become chylomicron remnants and just go straight to the liver. Once VLDL drops off tags, it's going to become a little more dense. It's going to become LDL. Now, LDL is different from VLDL and chylomicrons in that LDL is dropping off cholesterol to tissues. And LDL is taken up into tissues by receptor-mediated endocytosis. So once LDL is absorbed into a tissue, there's going to be an enzyme called ACAT waiting inside of a tissue to esterify cholesterol. So when cholesterol is esterified, it turns into a cholesterol ester, and that's the storage form of cholesterol. So ACAT is turning cholesterol into its storage form so that it could be trapped inside of tissues. Once LDL drops off cholesterol, it's going to leave the tissue and go back to the liver. Now, the liver is going to send HDL out to scavenge the blood for excess cholesterol so that HDL can bring that cholesterol back to the liver The way that HDL brings cholesterol from the blood to the liver is because it has an enzyme called LCAT inside of it. So HDL has LCAT inside of it. And LCAT does the same thing as ACAT. It traps cholesterol inside of HDL by esterifying it. So when you esterify cholesterol again, it turns it into its storage form. So we just want to store cholesterol inside of HDL while it's scavenging through the blood so that we don't drop it on our way back to the liver. So keep this straight in your head too. So ACAT and LCAT have the same job. They're trapping cholesterol just in different places. So ACAT's trapping cholesterol in all tissues. So I remember the A for all tissues. And LCAT is trapping cholesterol inside of HDL. So that's what I wrote here. All of their jobs. Now there's some diseases associated with lipoproteins. So there's something called LPL deficiency. So LPL is lipoprotein lipase, and think about what it did. It cut tags out of VLDL and chylomicrons to store tags in a tissue. So if we don't have the enzyme to cut tags out of VLDL and chylomicrons, then tags will stay in the blood, and that will lead to hypertriglyceridemia. Now, there's another disease called familial hypercholesterolemia. It's not as intuitive with the name, but familial hypercholesterolemia is when you have a defective LDL receptor. So if LDL can't be taken up into a tissue, where will it remain? It will remain in the blood. So then you'll see high LDL levels in someone with familial hypercholesterolemia. And I believe that I have that. There's another disease called familial LCAT deficiency. So think about what we said. LCAT is the enzyme that traps cholesterol inside of HDL. If we don't have LCAT, we cannot trap cholesterol inside of HDL. So where will cholesterol stay? It'll stay in the blood. So we'll have hypercholesterolemia. There's another disease called Tangier's disease. That's from having little to no HDL. And if we don't have HDL, we won't be able to bring cholesterol from the blood back to the liver. So where will cholesterol remain? It'll remain in the blood. So that'll lead to high cholesterol, hypercholesterolemia. So both familial LCAT deficiency and Tangier's lead to hypercholesterolemia. It's just that they're being caused by different things. So familial LCAT deficiency, what do you think it's caused by? Being deficient in LCAT. Tangier's disease is not as obvious. I haven't thought of a way to remember it, but it's when you don't have HDL. Atherosclerosis is the last disease associated with lipoproteins. So when you have hypercholesterolemia, when you have high cholesterol levels in the blood, it'll deposit itself on the walls of your arteries, and it'll build up plaques. And that will narrow your blood vessels, and when a blood vessel is narrowed, your blood pressure increases. So I hope this made lipoproteins make a little more sense.